We're going to graph the quadratic functions by identifying whether the quadratic function opens up or down, finding the vertex, and finding the intercepts. So our problem is f of x equals x squared plus 6x plus 5. So you first start by identifying your a value. So remember, this comes from the form ax squared plus bx plus c. Our a value in this case is understood to be 1. If there's no number there, it's understood to be 1. Now we can say our a is positive number. So because we have a equals a positive number, we know our parabola is going to be opening up. From just this piece of information, we know what our parabola is supposed to look like, and look, we can identify that the vertex is going to be a minimum number. So you start by identifying where it opens, then we need to identify the vertex of our quadratic. Our vertex in this case is going to be x equals negative b over 2a. So we have to find our x value. So we have negative, our b value is 6, over 2 times a is 1. So we simplify to negative 6 over 2, and that's how we get the x value of negative 3. To find our y value, we take the x value we found of negative 3 and we plug it in back to our function. So we have everywhere we see x, we're going to replace it with negative 3. So from here, we end up with 9 minus 6 times 3 is 18 plus 5, and this is how we get negative 4. So we found our x and our y value. Our vertex point is going to be the point negative 3 comma negative 4. So now we need to identify all of our intercepts. So you can start by identifying your x-intercept. And the piece of information we need to know is to find x-intercept, we know our y, or f of x in this case, is equal to 0. So we take our function, x squared plus 6x plus 5, and we set it equal to 0. To solve this one, as you can see, we're going to have to factor, so we're going to use our AC method. Our a value is 1, our c value is 5, 1 times 5 is 5. You look for factors of 5 that will add up to 6, so the factors 5 and 1 will add up to 6. Because our a value is 1, I know this is going to factor into x plus 5 times x plus 1. Now we take each of the factors and set it equal to 0, and that's how we get the x-intercepts of x equals negative 5. So I know we're crossing our x-axis at the point negative 5 comma 0, and from here we get x equals negative 1, and we know we're going to be crossing at the x value of negative 1, and we originally said y was 0. The next piece of information, I'm going to flip the page. We need to be able to find our y-intercept. In this case, the piece of information we use is, we know the y-intercept, our x is now 0. But remember the trick for ax squared plus bx plus c. If you have a quadratic of this form, your a and your b terms are going to go away, so you simply worry about f of 0 is equal to your constant. So go back to the problem. In this case, our constant is 5, so we know f of 0 is equal to 5. So I know my y-intercept is going to be the point x0, comma 5. Now you have all the piece of information needed to go ahead and graph your quadratic. So when you put it in your x and y axis, we have the points of our vertex, which is -3, -4. I'm going to write them to the side. We know our x-intercepts are the point -5, 0 and -1, 0. We just found our y-intercept of 0, 5. So I'm going to go all the way up to 5 here. I'm going to go all the way to 5 here as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have the point 0, 5. We have the point -1, 0. We have the point -5, 0. And we have the point -3, -4. The other piece of information we need to know, as you can see, our parabola is already coming together, but we need another point to match with this point. So that's where your axis of symmetry comes in. Your axis of symmetry is the vertical line that crosses right through your vertex. So if our vertex is the point -3, -4, the x value we're crossing is going to be x equals -3. So you can think of our axis of symmetry is this line here that goes right through our vertex that tells us the right half side of our parabola is exactly symmetric to the left hand side. So this point here is the point 0, 5. Our vertex is at x equals -3. So from the x value of 0 to the x value of 3, this point is exactly 3 units away from our vertex. So that means the other point that matches this point is also going to be 3 units to the left. So we are x equals -3, so we move to -4, -5, and -6. So the missing point is the point -6, 5. Now we have all the information. We can connect our points, make sure you give it a curve, and we have our parabola.